course in September. So this time around 2 years ago, I was just like you, completely new to artificial intelligence and the wider computer science profession. So I can totally empathize with you, how you're feeling and the questions that you may want to ask. So feel free to ask as you please. So you can pop it in the chat, or you can ask using the microphone. So I've got a PowerPoint presentation, and after that, towards the end, we'll be going through a short Python exercise using Google Colab, and that will be towards the end of this presentation. So I know it's an extremely warm day today, particularly in Birmingham. So I'm just sat a few minutes away from campus, and I can feel the heat. If you want to take breaks, feel free to do so. What I'll do is I'll talk for about 20 minutes or so, then we'll have a short break afterwards, and we'll take it from there. So we'll start with the PowerPoint now. So in most scenarios, the big data that you need for data analytic tasks you want to perform is not actually sitting there. So you have to pull it out, put it together, and make it usable. So in this presentation, we will show an example of acquiring and wrangling data by extracting and opening web data, largely from Wikipedia. And our goal is to introduce the basic data structures used in data science, data frames, tables, relations, matrices, arrays, nested structures, XML, JSON, and then show what is involved in getting remote, semi-structured and structured data into a form that we can use in visualization, descriptive statistics, or prediction. Along the way, we'll also introduce the basics of web crawling and HTML parsing, XPath extraction, and the relational algebra. We will then illustrate data integration and wrangling issues, including null values, joining, cleaning rules, and approximate matching. So I'll just move on to the second slide. So a typical machine learning course starts with data in a big, gigantic spreadsheet, a table, over which the analytics task is performed. In this table, the rows are instances, observations, samples, for example, a customer or a purchase, and the columns represent features, which are measurable properties such as a quantity and the price. Using this, you can perform various types of computations, such as reports for every quarter, how many purchases are made, and how many purchases are made by region. You can break it down as you choose. So in the 90s, this was called big data, and data warehouses were designed to create these types of reports. Companies like Walmart and their businesses competitors would rapidly create reports and eyeball them to, for example, make predictions of what stock to place in their stores and in what season. Obviously, we moved on since the 90s and things have advanced. So just showing spreadsheets and reports is not that interesting and may not convey meaning quickly. So as prospective data scientists, we need to turn this into visualizations to understand the data, and a number of great tools have been designed to put this into the hands of practitioners to enable things like interactive visualizations. Most people on the last box of this slide, they use a classifier which looks at new data and makes predictions about what it is or where it is going. As part of our AI course, just to let you know, you will be working on interactive dashboards, which is a fascinating module, and it's something that will really come into use when you enter the world of employment. So if we move on to slide number 3, so we'll start with the basics, abstractions of structured data. The data that we spoke about on the previous slide is an example of tables or relations. Tables are available in most popular languages used in data science. Python pandas are, PySpark, and where they are called data frames. Um, a data frame is a table with positions on the rows and names on fields. Tables are also the fundamental concept in relational databases, where they are called relations. A relation is a table but doesn't pay attention to order, so there are no positions on rows. There is such a small subtlety that we can just assume for now the relations, data frames, the CSV files are all the same things, just tables. So moving on to slide 4, the second type of structured data are arrays and matrices. We'll see more of them later on. In arrays, rows are still observations and columns are still features, but columns are indexed, they are positions rather than name. More importantly, rather than every column potentially having a different type, a name, which is a string, whilst a weight is an integer, all columns and therefore all entries have the same type. Apart from that, there's not a huge difference between two-dimensional array and a table. Third type of structured data that we will again see more of later on when we deal with web data and XML objects and JSON is nested data, which is represented by dictionaries. Dictionaries have a key and a value, pairs where the value can be simple, can be a string, integer, or a list of values, or a nested dictionary. Many public datasets are released by the government in JSON format. The example on the right is a dictionary from opendataphily.org, the Philadelphia Regional Government Public Dataset, and it is geocoded information about traffic violations in some particular location in the city. This data can be split into subcomponents, which again begin to look like tables. And in this presentation, we're going to focus on tables. So in general, we're going to pull data from wherever it lives, which is usually remote and not on our laptop, and turn it into tables. For example, we may need to analyze text or link HTML files, looking for patterns to extract the entities we are interested in. We may pull in data from remote databases or import CSV or JSON files. Somehow, we have to get raw data into multiple tables. Then there is a step in which we combine the table into a unified table. There are lots of tricks involved in integrating and cleaning the data, figuring out what fields you need and whether you need data from different fields. They need to be combined to create the data you need for the downstream analysis. Okay. We're going to move on to the next topic of structuring data. And that's this is a web data task involving Wikipedia. So we've got a Colab Python exercise on this, and the hypothesis is that chief executives of major companies are typically in their 40s or older. So suppose we are interested in knowing the typical age of CEOs of major companies. How do you do this using Jupyter Notebook on your laptop? Suppose we have a file of companies and categories. This is on GitHub, and need to find some authoritative data about CEOs. It turns out there's a list of companies and their CEOs on Wikipedia, which we're going to assume authentic and up to date. But it doesn't have information about ages, so we need to extract that information from HTML pages of chief executive officers from Wikipedia. The first two sources are already well structured, but the third is a bit complicated. We'll talk about this towards the end of the presentation when we do the Google Colab exercise, and it'll make more sense, a bit more application and practical exposure as well. So we'll just go into acquiring data. So the simplest way that people export data is through a CSV file. And during this the AI course, you'll be having a lot of experience with Microsoft Excel and spreadsheets. And the CSV, by the way, stands for Common Separated Values. And here there is one line of text per row with commas between attribute values. There's some variation as to whether the names of the columns are provided frequently as the first row of the file, or whether the column names are not provided. There's also an issue of what to do about commas that are part of the value of a field. So you'll have to look at the Python handbook to find out how to specify what type of CSV file you're working with. Now, we obtained the list of chief executive officers from Wikipedia. Quite a long, complicated list. Looks a bit confusing. The HTML shown has a table with information we need. The company name, for example, is Accenture. The CEO, for example, one here. As you can see, in blue is David Rowland, and he's got a title of interim chief executive officer. And there is one of these for each company. This is useful because the panda reach HTML command takes the HTML HTTP address and returns a list of tables as data frames. Now, looking at the Wikipedia page, we can see and know that it is the first table on the page, and therefore specify the index 0 as the data frame of interest. So in Python, the first value is 1. It starts with 0. Moving on to the.
Excuse me.
Oh, yeah.
I have one question. I have one question. Hello.
Hello.
Would you able to hear me? Hello.
Hello.
Would you able to hear me, Ham?
I think someone's left their microphone on. Okay, we'll carry on. So moving on to slide 14. Sorry, slide 13. So you can see the outcome of the reach HTML command that we've processed. You can see that it's a data frame with company and executive data. We presume it's the chief executive officer data. We can only presume at this stage. There are some funny things in the data frame. For example, interim chief executive officer with 1 in the brackets, where 1 probably is a reference to the source of information. We need to fix this later, which is a task for data cleaning. I've got a couple of slides on data cleaning, and you'll be doing a lot of work on this in the first few modules of the course. So we also need to use the name of the executive to find the Wikipedia page and extract information about when they were born. So it's not as easy as you may think it is. And I'll explain why in a moment. So going to slide 14. Another easy case, which is not used for this example, is if the data you want is in a SQL database, a structured query language database. With pandas, it gives you the ability to easily move data between a database and a data frame. For this class, we will use the SQLite, which is like a lightweight database, one that you could use as a personal database rather than one serving 100+ users. For a large number of users, you may use MySQL or Postgres or any number of the other relational management systems out there. They're just 2 examples I'll give. To talk to a database, you need to connect to it. You then put a data frame into the database using toSQL command and get a data frame out of the database by querying it. And the function that we use is read underscore SQL underscore query. With the to underscore SQL command, you specify the name of the table, the connection to the database, whether you want to overwrite the table if it already exists, and whether you want to save the index number from the data frame as a field in the database relation. In our case, the index is not helpful, so we'll specify it as false. With the read SQL query, you specify a query and the connection. The queries command select from the companies just returns all columns of all rows of the table companies, and this result is put into a data frame. Okay. So the story so far, acquiring data is easy if, and it's a big if. It's not the if that you typically use in Excel, but literally speaking, if the CSV has labels, HTML file with regular rows and columns, and it's structured in a relational database. Importing from CSV to or HTML can be slow, and the links can break. So using a database management system to store the data locally is a good idea. Be aware that database management systems is not part of the Jupyter notebook, so you may need to host the DBS database management system on a server on the cloud. You will do a short task on non-SQL using the MongoDB system. I believe it's in the first module as you join. It's quite an interesting task. It was involving who owns a fish, and there's lots of houses with different doors with different residents, and each resident has a different habit. So some may drink coffee, some may drink tea, and you have to. It's like a little puzzle, and you have to use store the data on using MongoDB and answer the puzzle. Quite a fascinating exercise, actually. Everybody enjoyed it. So we'll just finish these few slides and we'll have a little short break. So the next topic is extracting information from unstructured data. So, okay, here's a slide. You can observe that the executive names in the company can be appended onto the HTTP address for Wikipedia to obtain the web pages of chief executive officers. And this is where additional information such as the date of birth may be found. So we'll extract the names of the chief executive officers using a process called projection, which is essentially subset the data by column. Projection is written as this little code, as you can see, CEO underscore DF, and which where the arrow's pointing, using the label executive in pandas, and it yields a list of strings of executive names. So this where it's at the top where it says crawl underscore list equals, and you've got the two brackets, that indicates it's a list, albeit an empty list at the moment. So just be careful when you're using pandas. The symbols that we use, try to understand. So it's like a little command structure. So it's a list of instructions, and these special symbols, which will be introduced to you in module 1, are used to convey an order, an instruction. So moving on to the next slide. So that's just a sample of a Wikipedia page of this CEO, Donald Timothy Cook, and he was born in 1960. So as you have a look at the page, we can see the date of birth is in a special location on the web page, and it's in a particular format as well. So if we delve into it a bit deeper, you can see it's all a bit messy and a little bit confusing. So looking at the underlying HTML of the web page, we can see that embedded in the larger HTML document, there's a vCard table shown at the top, of which we eventually want to pull out the information about born. So that's the task. We want to know our chief executive officers in their 40s or older. And as you can see, it's highlighted in orange. We will do this using a language called XPath. And to understand XPath, it is useful to think of the HTML structure as a tree diagram. So I'll just move on to the tree diagram right now. And this tree diagram corresponds to the HTML on the previous page. So we don't want to go into too much detail, but it's just a visualization of what was said in the previous HTML text, and we put it into a diagrammatic version. And as they say, a picture speaks 1,000 words. So moving on to the next slide. You can recall that the born value is extracted using the XPath expression. We convert it to a datetime format. If there is no birthday, then it will be a null value, which is depicted as the NAT. NAT is the special null value for data type time types. For other types, it's a NaN, but for either, you will have to be careful of how to handle it during analysis. Null values are something which you need to be very careful with. You don't want to always delete missing data or incomplete data, because you can compromise the reliability. And in any case, it might be information which may appear small in volume, but actually quite critical. Sometimes you will throw away the row. Sometimes you'll calculate some value, for example, an average. It's not always a good idea. There are advantages and disadvantages to this. So moving on to the next slide, we've got this structured data, and is it all done and dusted? Well, not quite. We now want to take this data and check how clean and complete it is, and then put it all together. So we are moving from obtaining the data to some basic operations over data frames and SQL, projecting and selecting. They're the two processes. And in the next part, we will show these bulk operations using both data frames and SQL. So the next slide is data cleaning. What we'll do is we'll have at this point just a short 5-minute break. So if you want to come back around 10:45, and we'll talk a bit about data cleaning, and then towards the end, as we reach the end of the presentation, probably around 11 a.m. We'll move over to the coding exercise, which is quite interesting. Take a 5-minute break, and we'll see you again at 10:45. Okay, so it's 10:45. We'll carry on with data cleaning and single table operations. So moving to slide 25. Now we want to link between these two tables, but the names in the executive underscore data frame have underscores. So we need to clean the data and get rid of these underscores. So we're replacing the underscores with a space, which is illustrated by these two speech mark symbols, and in doing so using projection. So the formula is mentioned and is mentioned at the top of the screen, and then we apply it. Note that the Panda differentiates between data frame, multi-column, multi-row, and series, the single column, multi-row. The operations you can do over a data frame and a series do differ. So if the exec data frame clean underscore name command returns a single column as a series, the exec underscore data frame clean underscore name returns a data frame. And in this example, we are operating over a series and applying a function over each element. The lambda x indicates a function that is used just for this operation. We could have also done this using a for loop, but using apply signals as a bulk operation that can be executed in different ways. Parallelism, for example, a for loop would not allow this. This type of programming is very common for big data processing. Surprisingly, the built-in pandas apply as of 2019 doesn't use multi-cores, but it might in the future if you want to use Dask, Swift, Spark, and so on. The SQL version of the same thing is here. We're putting executive data frame in a table and renaming it, calling it temp underscore exec, and then using SQL to clean the data. No, the projection in SQL is done by specifying the columns to be projected over in the select clause. So select is a particular, very precise operator. Replace is a function that is taking the name as an argument and performing a replacement of the underscore by space. The result attribute is specified using the clean underscore name feature. Here's an example on the next slide. So for example, if you want to just look at one person, Kumar Birla, we apply a predicate to the series, sort of like an apply feature. This gives a true value for each of the elements of the series, a Boolean series, so true false is a Boolean. Okay. We can now extract rows of interest using the Boolean values to extract only those which have a true response. This gives us a data frame including only those rows satisfying the condition. Here it returns rows with the clean name, so Kumar Birla, without the underscore. So just a little summary now. So now we've have a basic set of operations over single tables. We focused on projection, so it pull out a slice of the table on certain columns. The next is selection, so it's putting out rows matching certain conditions. Third is the apply feature to commute over columns, and in-place updates for data frames, and the basic SQL select columns, expressions from and where. So these three operators are critical when you're designing a SQL database. So we'll just move on to linking data. So we still have the task of linking the two data frames together. And to do this, we use the bulk operation, merge or join feature. So join is another particular very precise operator used in SQL. So that the example fits on a slide, we will project both tables on the necessary columns. So we've got the data here, company, CEO's data frame, the executive, and company name, and it creates a data frame, not a series, with only the columns listed, which is the same as the exec underscore data frame list. So we'll just go back to example that we used before. We can also do this in SQL by selecting the result column we want in the result select clause. The relations to be joined in from clause, and using join on to specify this is a join. So just to emphasize these features, these operations select, from, join, on, these are particular commands which are used in SQL. You might do a little bit of SQL on the course, not a massive amount, but it's useful. It does come in helpful when you're applying for jobs, particularly in the data science field. Most big companies out there do want or do prefer some SQL experience, so it's good to get some experience in that field as well. And it might be some personal study that you want to do just to keep you up to date. So just going to move on to the slide. So there are millions of rows, and we can only lose 4, but maybe we don't care. But perhaps, what if those 4 missing values are outliers in an important way, the wealthiest or the youngest CEOs, and that might skew our results if they're dropped. So maybe we want to clean them a bit more. So it's not just a case of if the data doesn't fit, just get rid of it. There's a risk of compromising the integrity of the data, something called data quality. So the next slide is cleaning data at scale. In general, when we get data from the web, how do we know it's meaningful, whether it's good data? You need to know something about the data to see where it falls, where it fails, should I say. One of the worst mistakes data scientists make is not looking at the data. and they just go straight ahead running a machine learning algorithm over the data without doing any initial sanity checks, and that could potentially lead to very bad results. In addition to that, looking at the data, we might need automated techniques, particularly if you're dealing with millions of rows of data or even billions. It's not physically possible, mentally possible to analyze each row, make sure it's the type of data structure that you want. So we need some form of automation and validation. So the other thing we can do is to come up with automated checks for the data, most of which are somewhat incomplete. It is hard to capture all the exceptions. What some organizations do is to come up with a master list with rules about how it can be updated, but we can't really do this for web data. It's too vast, it's too complicated, and it's from multiple sources. So there, like many organizations would probably have like a data governance policy about how you update data and how things are added and what it's compared against. In terms of validation, there's slightly common sense, but names should not have alphanumeric characters, and birthdays should not be null values, and you must be aware of false positives and false negatives, and you could quite easily do that using a confusion matrix as well. So moving on to the next slide, was just an example. So to merge our data, here are some simple rules. We think names should have alphabetic characters, except possibly spaces, hyphens, apostrophes, and periods for initials. So we can create a validation rule for this. So like, for example, if you take the name Jean-Luc, it's double-barreled, it's got a hyphen in the name, so you can't always create a policy where you must not have a hyphen in your name or an apostrophe, so or Mali as well. So some people do have a hyphen or apostrophe in the surname, so you have to cater for that as well. And bear that in mind. So let's get back to an example. So right, when we run this code, this is what we get. We find names with special characters in them. And what do? We can convert them to a clean form through a conversion process. In this case, there are HTML codes, so we can write a function to turn them back into characters. But this is time consuming. So what we'll do is we'll focus on a more tolerant version of this joining process. We'll focus on a little bit on record linking now. There are many tools that can be used to do a more tolerant version of the joining process. And there's a few mentioned here: Hamayoun, Data Ladder, Quality Stage, and so on. We'll try to bring more context into this now and present wrangle data and plotting and grouping the data. So what do we do about the null values? One option is to drop rows with null values in certain columns using the drop NA command. This will drop rows if there are null values in any of the columns. And here we restrict where the null values are looked for, i.e. the birth date, using the subset column name born. Another option is to fill in some sort of default value. For example, you take the mean or the mode, but the downside is that you risk skewness of data, and that could compromise data quality. I'll just talk a little bit about grouping the data. So going back to our objective is to understand whether or not most CEOs are 40 or older, and so what we're trying to do is to get an idea of the distribution of birth dates. So here we group the chief executive officers using the group by feature, and then show the group that was on, in this case, 24th of August 1945, using the get group command. This is just for one example. This man, Vince McMahon. Okay. We'll talk a bit about grouping and aggregation now. So now we want to count how many CEOs are born on each day, and for this we use the count function for over each group. So not many CEOs share their date of birth. You may get a small number, but the majority do not. And we can do the same in SQL using group by born command to create the groups, and then putting the count, company count, in the select clause to do the counting. So slowly coming to an end of this presentation now. Get a better sense of data birth date clusters. We will group them into decades and plot by decade using a bar chart. So first, for every non-null born date, we will calculate the decade. So for example, if they were born in 1945, it would be 1940s, and on the right you can see in speech marks there's a little S. And we'll use the apply map command, and then add an extra column called born decade in the exec underscore data frame column. So now we can kind of bring this into more of a rational format. So we can plot it using this bar chart. I'll just put it up. So as is pretty self-explanatory, it shows the number of CEOs born in each decade. And as you can see, it shows that most chief executive officers born before the 1980s. The biggest decades are in the 50s and 60s, meaning that the age of most CEOs is about 50 or 60. So we'll just summarize now what we've learned. So no tuple can be in more than one bin. Just be careful, tuples are immutable. That's a new concept. You'll learn a bit about that, I think, in the next presentation at 11:30. And you need to make sure that the bins are in the right structure. For example, like decades instead of individual days. And grouping and aggregating is sometimes also referred to as reducing, not very often though, but I think most people nowadays just refers to as grouping and aggregating. So just to conclude before we move on to the collab, so just to summarize what we did in this presentation, what I talked through, we looked at basic mechanisms for getting having the data from CSV, HTML tables, and relational databases. We also looked at extraction from HTML documents based on patterns via the XPath. And we also looked at basic table manipulation, including modifying schema and data, and they were projection, selection, and merge. We also looked at linking data by value and by similarity, basics of data cleaning, and some simple grouping and visualization. So we'll just have a very short we'll just call it a little tiny 3-minute break. I'll just load up the Google Colab and then I'll put all this into context. It's far more fascinating looking at it from a coding perspective, and you'll be doing a lot of this in your, particularly in your first and second module. So if we come back at say 10 past 11, then I'll just spend about 10-15 minutes talking through the collab, and then you can have another short break before you move on to your next presentation with Salami at 11:30. So see you again at 10 past in about 3 minutes. Okay, then you should be able to see this Google Colab. I'll just spend just a few minutes just to really just go through the codes and the way the data is structured and all the instructions that you have to iterate through as you process the data, and I'm trying to bring some meaning into it to gain some insight. So the first thing is on the left-hand side, you can see the CEO's data in a CSV format, and then you've got the local database loading as well. So it's a massive file. It's difficult to open on a standard laptop, so that's why you need a platform to process the data. And then we install various libraries. Don't be put off by all this complicated jargon. I can assure you it does make sense the more practice that you get. And the good thing about this MSc AI course at Birmingham City University is that you do get an abundance of uh, experience on the application of knowledge. So you'll be giving some scenarios, and some of it will form part of your assignments as well. So you load the libraries, and as you can see, we use the import feature, import pandas, and then we give it an alias. We just call it MP, and NumPy is MP. And then you refer to them as this when you load your data as well. It'll make more sense as I go through the presentation, this notebook. So here we load the data from its source. And as you can see, we've got the link of various sources. It's very cluttered. It doesn't seem very pleasant to look at, and a lot of this is irrelevant. It needs to be cleaned. It needs to be sanitized, and that's what we're going to do as we work through the presentation. Again, don't be put off by the lots of coding and this different symbols and language that's used. It's not as complicated as you may think it is. So here we are. We load the data frame, and we've called it company underscore CEOs underscore data frame. And you've got various columns which are labeled. And moving on, the problem gets harder extracting structured data. So we set up a list, and we've called it crawl list underscore list, and that brackets, as I mentioned, is a symbol for list, but it's an empty list at the moment. And then we use the for instruction. So we're looking for an executive. So the for executive in the company underscore CEO underscore data frame, and the label column that we're using is executive. So you put it in speech marks, and just be careful when you are processing the data that you use exactly the same name. So one of the common problems, particularly I had, and lots of the students on the AI course, was that sometimes the format that they enter the data, whether it's a lowercase or uppercase, or sometimes a typographical error as well, that can cause some problems when loading the data. So it's quite critical that when you are extracting data from a CSV file, you process it in exactly the same format. We'll just move on a little bit more. I'll try not to make it too complicated. So it's just really for you to kind of get some understanding of what we talked about in the presentation. Like I said, it's probably a lot more complicated with all the lines of code, but it's basically little instructions that are being processed. So we'll move through some of the extra jargon. And if we look here at the executive underscore data frame, what we're looking for, the column name, page, born. So what we could do, the good thing about with Python and various other programming languages is that you can specify exactly what you want to look for. So in this case, we're only interested in the name, page, and when they were born. The rest you could drop or remove. So as you can see again, name, it's got the underscores in it, and we want to get rid of them. As well, also the date of birth, some of it is missing, so we need to do something about that as well. The NAT, which indicates the data is missing. So moving through cleaning and manipulating the tables. So again, we want to just focus on the name and when they were born. So using the date frame executive underscore df, we just focus on, we condense the data into the two columns that we want to focus on, and it's a bit more easy on the mind as well, far more rational. And next task is to eliminate the underscore mark. So this is quite a simple line of code, very, very simple. So we've called it clean underscore name, and what we want to do is replace the underscore with an empty space. So we just put two little speech marks, and there's a little gap in between. So you'll notice, for example, like Judy Sweet or Kumar Birla, that underscore will be replaced by an empty space. And you can see in the column on the right, that's exactly what it's done using this simple line of code. Okay. So we created a new column, clean name. The old column was just called name. We've transferred the data without the underscore. And then we can do the same using SQL as well. Again, it's pretty identical, the outcome. Okay. And there we have it. If we just look at the executive, chief executive's names, you notice it's nice and clean, it's rational, and that's because we cleaned it and we gave it a new column name, or clean underscore name. And over here, if we take the CEO Kumar Birla, as you can see, there's some missing data, false values, because their names still have an error in them, or they're not following the condition, the command that we set. But it doesn't for Kumar Birla. So over here, it's true. And if you look at the column over here, it's highlighted in blue, you can see that that is the second CEO. Okay. And putting it all together, this is using the joining feature. It's also covered in SQL as well. Some people refer to it as concatenate. So you can also order which side of the data frame you want the executive name. So whether you want it on the left or the right, you can put that in the command as well. And that's a cleaner format of the database. If you just remember how it was before we started, how it looks now, it's far more condensed, it's far more rational. I'm not going to go into too much detail. I think we covered a lot of it in the presentation as well about similarity projection. We can also group the data by when they were born. And if you look on the right of this code, we're specifying the date of birth in a particular format. So it's year, month, date. One, the count feature, it just counts the number of executives who were born on a particular time. So as you can see, most of them don't share the same date of birth. And you can do the similar sort of thing with SQL as well. And there we have it. So it's all in decades. It's only an indication whether it's in the 40s, 50s, 60s with a little s at the end, and that's done using this little line of code in the middle. And we've got a little mathematical formula as well. That is something that you can use with Python. You can put in your own little operators in if you want to present the data in a particular format. So there is a little exercise at the end. Is there a correlation between the kind of company and the age of data, the age of the CEO? What we have found that is data is so vast, it is complicated, it is not clean, sometimes it is not structured, it comes from multiple sources. And what we have talked about in this presentation and just briefly ran through using this Colab is that we need to sanitize the data, we need to clean the data, we need to visualize the data. But before we do all of that, we need to make sure that this data is well structured and is clean. And that's one of the key roles of a data scientist, is when you are presented with data from different organizations, different departments, different sources, is to make sure that it is clean and you can visualize it, you can present it to in a report to your directors or whoever the end user may be. So that is the end of this presentation now. I believe Ian is about to join the call, and we'll hand over to Ian.
Thanks, Hamayoun. So if anyone's got any questions based on what Hamayoun's been talking about, the data wrangling or that activity as well, please feel free to drop them in the chat. You've all been sent an email with the Google Colab links and the files for the slides and the activity, so you can run through this in your own time as well. So thank you very much, Hamayoun. So we'll make sure that the recording's uploaded. So I'm just going to stop that now.